Alright, we are finally going to finish these pages here. We're going to talk about surface area of composite figures. And surface area of composite figures really doesn't have a formula per se. What we're going to do is just break this into pieces and find the actual surface area. And I'm going to label the pieces and then shade them in after I find the surface area of that piece to help me out. So I'm going to label this A, and I'm going to find the surface area of A. And A, let's see, let's label all our sides first. So this is 10, this is 10, that means this is 10. This down here is 10. 10 by, we need this length. So if this is 80 and this is 60, that means there's 20 left over for this one. While we're doing that, this is 80, this is 60, there's still 10 up here. This is 60, this is 40, so this is 20. Might as well go ahead and label some things we need. So A, this box right here, is just 10 by 20, which is 200. And we'll add all that together later, but I'm finished with that section. All right, let's move on. Let's keep going with this piece. This is B, let's say, and that is 10 by 40, which is 400. That takes care of this portion. Okay, let's do this one, which is C, and we've actually got two, the front and the back. And this is 20 times 60, which is 1,200, but there are two of those we said, so that's 2,400. And I've done both, so we're going to shade in, hey, I've done both. Now, I'm going to do D, which is going to be this piece here, okay? This section right here, which is 60 by 10. I'm going to label that D as well. This D is right here. 60 by 10, and there's only one of those. So that is 600. Okay, so I've done all of this except for this bottom part here. Okay, haven't done this bottom part. We're going to shade that if we need to. We haven't done this bottom part. So let's go ahead and do that bottom part next. So this bottom section right here is 80 by 10. I'm going to label this bottom section, this is E down here. And that's 800. Okay, so we've done the bottom section now. Now let's do this piece right here. We've already counted this section of it, so we only need to do that section. And we have a back to that as well, and I'll say that's F, so there will be two F's. Okay, so this is 60 by 20, which is 1,200. And there are two of them, so that's 2,400. I need to change the ink, evidently. Okay, so that is this front. We've done the bottom, we've done the front and the back. We need to do this section as well as this section. So EF, let's see, G. We have 10 by 20 for G. There's only one of them. 10 by 20 is 200. Definitely have to change the ink. We've done this section, and the last section is H. Now, I don't have a bottom for H because E was this whole length here. Okay, so this is 10 by, let me see, this is 80. This is 20. This is 60. It says it right here. It might help if I could read. Now, couldn't it? So this is 10 by 60 for H, which is 600. Once you have found all pieces, like we just did, we are going to add them together. So 200 plus 400 plus 2,400. Yes, you can do it in your head. I always make common mistakes on accident. Okay. And that is 7,600 millimeters squared. All right, I want you to pause the video and try example 2. Example 2. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . You've got enough time, or you paused it, you should have paused it, to do example 2. Example 2, I do have a little bit of a problem here. And that's it. This right here, in a minute, I'm not going to actually, when I find the surface area of this section here, I'm actually going to subtract a base right here, okay? All right, but let's just find the surface area of the box first. That's actually kind of easier because we have, 6 sides, pieces, or whatever here. So I'm going to say this is A, and there are 2 because there's the front and the back. So 10 by 25 is A, and that's 250. And there are 2 of them, so it's 500. Okay, so that's this section and the other side. Okay, this is B. We've got this section and the back section, and this is 40 by 10, or 10 by 40, doesn't matter. And there are 2 of them. That's 400 times 2, 800. Okay, and then I'm going to do the top, and there is a bottom here, so let's say that's C. And this is 25 by 40, because this is 40, this is 25. So 40 by 25, and there are 2 of them, and like I said, sometimes I make simple math mistakes, so let's type in just to be sure. Yep, 1,000 times 2 is 2,000. Okay, that's the box. Let's talk about the cylinder. We're going to find the surface area of the cylinder. Okay, we are going to subtract this bottom, but we actually are going to have to subtract it twice because I need to subtract it from when it's the cylinder and from when it is the actual piece of the rectangle. I'll show you kind of what I mean by that. For instance, if I've got this glue stick sitting on a algebra book, right? The surface area, the piece that's actually in the surface here, I don't need this cap piece. I don't need the piece that's actually touching the book because that's not on the surface. But right here it's counted twice. So I actually will need to take the area of that base out twice because it's counted twice. It's counted once here and once when we do the surface area of the cylinder, okay? So the surface area of a cylinder, remember that formula, and if you don't, I'm going to look in my foldable here. The surface area of a cylinder, so we're just going to do the cylinder, A, B, C, D, we're going to call the cylinder D. So the surface area of the cylinder is 2 pi r h plus 2 pi r squared. And I'm going to leave it in terms of pi for right now, okay? So 2 pi, the radius is 5, the height is 10, plus 2 pi times r, which is 5 squared. 5 times 10 is 50, times 2 is 100 pi, plus 5 squared is 25, times 2 is 50 pi. Now, you do need to know, by the way, that when you're adding these, it's like adding like terms. You do not change the pi's, but it is 150 pi. Now, that is the whole surface area of the cylinder. I need to subtract the area of this circle twice. So the area of just the circle, either one, they're the same. The area of the circle is pi r squared. But I'm going to have to subtract 2 of them. But the radius is 5 squared, so it is 25 pi. But I have to subtract 2 of them. So I have to subtract 50 pi. Now, what I'm going to do is put all of these together. So 500 plus 800 plus 2,000. 3,300 plus 150 pi plus, no, minus 50 pi. I am going to use the pi button to the nearest whole number. I'm going to round right here. I do not need you to round until you get to the very end. But see, now I'm going to round this. I'm going to type the whole thing in my calculator just like that. 3,300 plus 150 second pi minus 50 second pi. 3,614 centimeters squared. All right, you're going to work on that sandcastle piece that you have. Okay, so go ahead and pull that out and get started. Glue this, if you didn't the other day, to 141.